What's up YouTube? This is Carmelo from Fingers of Fury. I make finger training equipment for climbers. So today I'm doing some material testing. I'm actually going to, probably after I ramble now, edit in a video that I took the other day where I test this Big Boss here, which I'm working on. It's a lighter version of the Big Boss with also these grips on top. I tested it with some ABS grips on top, and what I expected to happen was for them to break, and I got to about 1,500 pounds. There's a, what do you call this, a chain hoist here with a crane scale and some straps and stuff, just to kind of get away of testing how much load I can put on this. I'm not so much worried about the Big Boss itself. This should be pretty close to the amount of weight that the last versions held, which I had somebody load this up, or the previous ones, to 2,000 pounds, and it just, it did deflect under load, but not actually bend. It didn't yield at all. So 2,000 pounds. I can get it to 1,500 with this, which I did, which again, that's kind of what I want to talk about. What I'm doing right now is kind of dumb, or at least what I did in that video is kind of dumb, and I just want to point that out. So what I'm working on is choosing the material type here. I'm 3D printing these, and so there's plenty of 3D printing materials out there, but I'm trying to figure out what works best for me. And so this is a PAHT carbon fiber. I think this is what's going to end up being the material of choice. And I guess the biggest problem I'm having is some of these, or all of these stronger materials basically are very stiff. So this PAHT is not quite as stiff as I was testing PET CF, which was my previous, I thought was going to be the winner. So it's quite stiff. So basically my choices were, or as far as my thinking was, a PHT carbon fiber, or a PAT, or a PET carbon fiber, PET carbon fiber, which is also very strong, and doesn't absorb much moisture. So of 3D printing filaments that people might be thinking that could be viable for this is, people might even think something as simple as a PLA. PLA is quite strong, but it can creep. So it's not going to be the same shape as it would be, you know, I don't know how long it could be, I can't say, be different in different environments, especially if it's in somebody's trunk, like in Texas or something. That thing's going to move, and you might not notice that on a lot of things, but something where I'm interfacing with another object, what might happen with creep is that these are flexing, or they're being flexed out a little bit by these little tabs that I have in here, and I want that fitment to be consistent always. I don't want these to be like falling off of people's boards, so I don't want creep to happen, is one of the things. So I want something that won't creep, is fairly temperature resistant, like in realistic scenarios. So off the top of my head, the only thing I can really think of is two things for climbers: is A, leaving it in the sun at a crag, or B, in your car anytime, you know, whether you're at the gym or the crag or whatever. And you know, maybe somebody would leave it on their dashboard or something. All of those might hit temperatures where PLA probably wouldn't stand up to it. If you had something like a PLA with even a carbon fiber, that would increase its heat deflection temperature, but I don't know that it would prevent it from, say, degradation. So basically lower temperature plastics are going to degrade much faster at those elevated temperatures. So it might not even deform, but something like a PLA is going to degrade faster over time, which is also a no-go for this. And it gets brittle. I've noticed that some of the stuff that I've printed in PLA over the years, like, it'll work for years, and then one day I'll just drop it on the ground and it will shatter. Saying that something is PLA, it isn't an all-encompassing description of PLA, because every brand is different. They have different mixes and stuff. So I can't tell you, you know, 8 years ago when I 3D printed something and then dropped it, what was that PLA? I can't say. So PLA is a great plastic. It's super cheap. So like the strength to cost ratio is incredible. Nothing can match it. It's definitely one of the best 3D printing materials. But as far as like a consumer product, PLA I just think doesn't cut it for me. You might be thinking, other nylons like PA6, PA612 or 66 or 12. Those are great, and what I like about those is that they're not nearly as stiff as even this PAHT nylon, but the absorption of water and the creep is also a problem with those. So those nylons can creep a lot, even if they have carbon fiber added to it. It helps a lot, but probably not enough. What I do like about the fact that it absorbs the water is when it does, the overall tensile strength will drop quite dramatically, but the toughness of that is going to rise up a lot. So what that would help with is, you know, the toughness and like impact resistance would be nice. Is, you know, maybe you drop it out of your pack or something and it lands on a rock. The impact resistance is going to be that mechanical property that would mean that these won't break. Honestly, I don't have like an Izod or Sharpie impact test machine here, but I've been smashing these leftover ones with a hammer, and these are quite tough, tougher than the PET carbon fiber. Not as tough as, say, even a PLA without anything added to it, or like an ABS, but quite good, right? So, and some people are using PLA carbon fiber, which is already a super brittle material, can be. Once you add the carbon fiber to it, it becomes very brittle. So this has been an awesome material. And the stiffness, again, I might have picked something less stiff, but what it does make for is a super satisfying click. If I can get that on camera, it's super satisfying. And as you can see, I can put it in and pull it out quite easily. And then having something that is a bit harder with this carbon fiber in here and wear resistant makes it so, as it's going in and out of this many times, is it's not wearing as much. So on those softer materials like the PLA and the ABSs, I could see just from doing this a bunch of times that I was wearing the tabs I have on the inside of this part quite quickly. I do want the plastic to wear, obviously not the aluminum, so you don't want something crazy hard going in and out of there. But so that's the rundown of my material selection. I know I'm forgetting a lot to talk about, but as far as I want to go over mechanical properties a little bit, and I've got this dialed in such that so there's inserts in here. I don't know if it'll pick up a black on black, but so I can flip that upside down. However, the inserts are in there, so you can pop those out quite easily. You know, again, the inserts also don't fall out, but they go in here. They're held in here, super nice. And this also ends up as a kind of secondary design feature. I probably explain this again in the video that I'm going to cut to, but in testing, I have, let's see if I can find it. Before I ever made this in aluminum, I made these little test pieces, and this is a PET carbon fiber, so it is super strong, especially in compression. And I put this on top of it, and I have this little piece that I put over here, and then I put this in a hydraulic press and measured the pressure that I was pushing down on this to see how much force these could take. I did PLA, I forget, it was like, I'm gonna say 300, it was hundreds of pounds, and I think this made it up to like 1,200 pounds, or maybe that was actually the PET carbon fiber, but it was quite strong. But the weakest point of a 3D print is always in the Z direction, so I print these standing up like this, so it always break along the layer lines here. And so these higher temperature plastics had a better layer adhesion than even a really good PLA that I've been using. So why that's important is I didn't originally have this piece here, and what I was always worried about is, what if this does break? What if something I didn't think of, somebody drops it on the ground? Again, I'm doing my due diligence in testing the amount of force that this can take, and it's wildly above what any human can produce. But if there's something I didn't think about, and this were to break under load while somebody was using it, I've left these aluminum tabs sticking up. I also tried to make it where you wouldn't put your hand, but what if? That what if honestly scared me, and it made me create this little insert holder here. So even if this does break, your hand will only go into this, and that should be no problem. It wouldn't be comfortable, but I don't even think you would hurt yourself even in that scenario that I can't even think of how it would happen, you have this here to protect you, and you never get close to these somewhat thin tabs here, right? What that also did, and I wasn't even anticipating this, I did make this so it comes up right to, I have some kind of like ceilings in here that it's very close to touching those when this goes on. I leave enough clearance so they don't interfere with each other, but if this bends slightly, it will touch that. And I think that's why in the video that I'll cut to, that even when I'm using ABS, which is even weaker than PLA in every way, is I was able to get 1,500 pounds on a Big Boss on ABS grips. I think it's because basically I never end up putting this in tension, whereas when you squeeze it, even though I'm pressing down on it, this will bend and the inside here will end up in tension and it will rip the layers apart. And that's the failure mode that I would see on the press. So with this here, that actually never happened. So it's even stronger than when I was testing it in the hydraulic press. So this is just wildly strong now. So I've lost my train of thought at this point, so I'm gonna cut to that video and then I'll explain what I'm doing now. What's up everyone? My name is Carmelo and this is Fingers of Fury. Today I am testing the Big Boss. So I'm just gonna get right into it. I'm like in between things and I just got excited to do this. And so I'm gonna point out the ridiculousness of this setup doesn't escape me. I'm just super curious and wanted to do this. So I'm trying to bust the grips on there right now. I'm starting with ABS. I'll talk about materials and stuff later. I'm just gonna break them because that's what I wanna do. So let's go. Okay, that's 600. That's 8. Oop, so that's 900. Ooh, so that's 1,000. I don't know if that's a good idea, but that's 1,300. This is supposedly, I think, a 2-ton, but it gets really hard to pull at around 1,000. So that's 1,300. That's 1,500. I don't know how much further I want to go with this. All right. That's a lot of stored energy. So I'm gonna back off a bit. Take a look at it from the other side. So I already know that the board itself isn't going to break. These have been tested for they're over 2,000 pounds. What I am worried about is getting smacked in the head. The plastic grips on themselves I've tested to about 1,000 pounds for a PET variant of it. It shouldn't go flying, but all I've got is these safety glasses and not some sort of enclosure here. Let's see. No, that's it, 1,500. Let's take a look at it. So you'll see what I see, This is it afterwards. I don't see any gap like right here or anything forming. So that looks the same. Let's see here. So I didn't have a straight edge here, but this is the original Big Boss like prototype #1. And so it's still flat, which I kind of knew would be the case. So I wasn't too worried about that. Let's pop these off. Still easy to pop off. I don't notice anything there. This is usually the easier side to pop off. Man, so what I have to do is break this. Okay, so that broke. So I've done this to every single part that I've made. It's very easy to do on the ABS. Super easy to do on the PLA. That is some force. So what's important is that that's difficult to do. I can break all of them like that. So the ABS, what's nice is it bends instead of breaks. And what you want to be able to do is it needs to be strong enough to at least pull wherever I may pull. So it's meant to be pulled here from this little finger hole here. But on some materials, if I pull it like here, it'll rip that backside off. So I gotta make sure it's something that won't do that. So anyways, this didn't turn out the way that I thought it would. I thought that this was going to break. Obviously the nylon carbon fiber can do it, but it might be that ABS could also be a viable solution as well. So I'm gonna keep that in mind. I've got some more investigation I got to do now that I've discovered that, but so we'll see. I'm gonna call it here because this didn't go as planned. I was going to test the nylon, but I know that it's gonna be more than that. I know I can't break it here, so I'm gonna call it for now. All right, so I'm a bit out of camera now, but hopefully you can see okay. So what I've got here is to kind of clarify what all my thinking and my material choices. I kind of, after I had that hopefully clip that I just showed you just now, I was like, I need to just think about everything a little bit more. I want to test everything. I don't want to take anything for granted, and I just wanted to test all of my materials. And if you're into 3D printing, you've probably seen these hooks before. If not, these are just some hooks that it's Stefan at CNC Kitchen. If you search on YouTube, he does some strength testing of 3D printed materials. But again, like I was speaking to earlier, is that unless you're testing the particular filament that you're using, and even more specific in the machine and the environment that you're using, then you're not super confident in the results that you're getting. So I even, for this material, just as I have time, I'm printing these out as I'm switching materials. This is the PLA that I'm using, which happens to be a Sunlu PLA, which is cheap but very strong. There's another channel, my Tech Fun on YouTube, where he tests materials, and if you pay for his Patreon support, he'll provide you with an Excel spreadsheet of all the materials that he's tested, and you can compare them to each other. And this brand here, for the PLA Plus, not the regular, or they have like a Plus 2, this ends up being like wildly strong adhesion that is close to some of what you'd get in some of the nylons, but very cheap as well. So you can buy these in in bulk orders and get it. So again, I don't sell anything in PLA, but this is what I use whenever I'm prototyping stuff, or you see like fixtures around my shop or whatever, printing stuff for my house. This is always what I've used, and it's been a really good PLA. So as a starting point, I'm going to test this and see how strong this is, and then I'll know when I make a prototype how other materials are going to stack up compared to this. This is, as far as mechanical tests go, this will only test the tensile strength. So I'm not really finding out anything about its impact resistance or anything else. This is really just a very super simple test. right? And I've got 2 different styles. I've got 3 of each. One that I print like this on the print bed and one like this, and that's why this design looks the way it does, is so you can print it in both orientations. So that's why it looks the way it does. So I'm probably gonna do some very slight editing on this just for it to not be as boring, but I'm going to work through some of the pieces, and I'll probably just say out loud what number I got. I don't know if you can see on the scale here what I get, but I'll kind of make sure that that gets edited in, and I'll be keeping track of this as I go. Glasses. Ooh, 134. Okay, so the first one is 134. Again, still not the greatest setup, but this is the amount of energy in this is obviously way less than the 1,500 pounds I would have on the Big Boss. And so just the way that this failed as well, you can see it didn't break too brittle, and it's 134 pounds. And I just have that as a baseline. And I'm gonna be writing this into my iPad as I go. Okay, 140 for that one. And I'm doing these as slow as I can. The sampling rate on this, I don't know what it is, but it seems very slow. So as slow as I can go, I try to do that. 140 again. Interesting. Okay, so for this one, the first 3 were printed in the horizontal orientation. This one's going to be the vertical, so we should see something much less. I forgot to hit hold, so I think it was 80. I'm having some weird zeroing issues on this. It keeps on going -3. I'm gonna do it again. It's probably gonna mess up. So again, I think that was 80. So that's 87 if you can see that. So I'm gonna do 80 and 87. I know I kind of missed the last one, but I'm gonna put in 80. But you can look at this. So this is where the pieces are breaking, and I'll try and see if I can get that to focus better if I get out of the way, perhaps. But this is, I don't know, maybe a centimeter by a centimeter. And that took 87 kilograms of force to pull the layers apart. So even though that's way less, that's, you know, pretty impressive for the cost of this plastic. All right, so 77. So seems to be right about in the area, or they seem to average out pretty well. I'll move to the next one. Cool. So this next batch is actually the same material on a different printer. £103. 112. So what I'm noticing on this is that I realized as I started printing these that I need to keep track of the settings that I'm using in the printer to print these out. This other printer is getting less. This one's 112, so it's around 100, 110-ish pounds of force to break these. However, it is on a different printer, but I used way less walls. So it's not as much a test of the printer, but the settings that I used in the slicer to do these. So not the greatest of data, and I also forgot to write these down. I'm going to put what I think I remember. 108, 109. So I'm not going to be too careful with these. Again, I botched printing them out, but quite frankly, for the amount, it's not crazy. That's off for how much less walls. So it still kind of validates that both printers print it well. And again, I'm as far as printing stuff out, I'm not doing this to get like the most accurate data realistically. I want to get kind of like a baseline, what to expect from these materials. So again, I don't want to profess that I'm doing the best tests here. So I just want to get a basic baseline. Okay. So for fun, I've got some weaker materials here. Let's do one of the stronger ones, mix that in here. Let's go ahead and zero that back out, maybe not, -4. Again, I'm not gonna worry about it, make sure I hit the hold. Pop this in here, pop this in here. So if I didn't say it, this is the PET carbon fiber. Let's see how this goes. And this is the horizontal orientation. Let's see if this stuff's really strong. $120-ish. Okay, 150. So we saw at best 140 with the PLA. So you can see PLA is crazy strong for what it is. PET carbon fiber, 144. So that's similar to the PLA. So again, I wasn't mindful of the print settings. This one's even thinner than the PLA I was complaining was thinner. So I can't really make out the walls on this, but the thickness of it, they meld together perfectly. So there's maybe only 2 walls on this. So it's getting a strength similar to the PLA, but at much less walls. So this isn't super useful data, it's maybe usable in a way, but it's not for comparison purposes. Okay, so this one is the PAHT carbon fiber. At this point, I'm kind of contemplating with whether I even put this on YouTube or not, because I rushed printing these out and doing this whole test, and my intentions were good, but clearly I'm just gonna have to redo this, standardize how I print these out. I'm using 2 different slicers, blah 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 blah. But so I want to see how the PAHT goes, at least, and see what settings I even use. So let's do that now. Okay, so that's 173 there on the PHT carbon fiber. This even failed completely differently than the other ones, right across there. I can't even really tell from how this broke, how many walls I even used, but it is interesting to see how that failed along here. Pretty cool. Again, much higher than the other one, so let's keep going. So that's 181 there, if you can see that. And that's 183 on that one there. 183. All right, so I lost video for a second, so I guess I'll find out later if the rest of it got recorded, but this is 72 pounds here on this test, and it seems to be similar to the PLA that I was doing. So the PLA, again, still really strong for what it is, and we'll see if we get similar results. 70, 72. All right, so I've completed this test. Again, I'm contemplating whether or not I even turn this into a video or not, because these are vlog style things where I'm kind of just documenting what I'm doing, and I'm running around like crazy and then turning on the camera and just shooting whatever it is that I'm doing at the time. So I've got two kind of big failures here, which is, I took a video of me being kind of stupid, and then I've kind of uncovered that I didn't even get settings correctly. I'm running these little hooks in between running actual parts. So I'm like changing the settings for actual parts, whether it be like I was 3D printing a climbing hold or this grip, and other stuff. I've been having the 3D printers run kind of constantly while having the CNC machine running constantly as well. And so in that, I missed that I'm totally changing the settings on these as well. Sometimes I'm importing these parts into the current build plate that right after printing something else. So again, I've got probably a little bit over 70 pounds of force to break the PHT carbon fiber, which is still a little bit lower than the PLA, which is way more affordable. We're talking probably $80 a roll for the PHT carbon fiber, where it's 13 or 14 bucks for PLA. So again, the price to strength ratio is wild on PLA. Like it's so affordable for the amount of strength that you get and usability that it has. However, looking at this again, it's not an apples to apples comparison, because for whatever settings I had for that initial test on the PLA that you saw that I got, sorry for being off camera for a second, I got, let's say, average 80. And then on the second machine that I used for printing the PLA, I had maybe average 60 pounds. So the 60 pounds, however, that I got, these test hooks were probably closer to what the PHT was printed in as. So is the PHT stronger? I've kind of already proven that it is by doing another test. Again, I used PLA for the top grip. Originally, when I did the hydraulic press video, which you can see on my Instagram, is it fails along the layer lines. If I print it in PET carbon fiber or one of these nylons, is that I get a way higher force. And again, it's always breaking along the layer line. So even on this layer adhesion test, where the PLA seems comparable, I know that it is from the tests that I had, the independent tests that I have from the Excel spreadsheet I told you about earlier, is that the PLA has a wildly good adhesion, and that's due to it being a lower temperature plastic as well, which has its pluses and minuses. But again, with less walls, the PHT is able to get close to that PLA, which is still phenomenal. It's a harder wearing material, and again, the temperature resistance is much higher. And then also, I mean, even in that horizontal orientation, it's much stronger than the PLA. It has a better feel. That the carbon fiber always adds this texture to your parts, and again, I can see that that's not coming out super well on camera, but it adds this texture to the part that really hides the layer lines, makes it look like it's not even a 3D print anymore. So all in all, I still think this is the best material to use for the properties that it has. I will be printing these out and retesting. I don't know that I'll do a video on that. I'm about to be a lot more busy moving forward, so I don't know that I'll have a lot of time to turn on the camera. So I guess this will be proof that I am at least trying to test things. This is, my setup rig leaves a lot to be desired from safety and usability. Both combined. This scale isn't very good. This is my power rack here in my gym area that it just kind of gets in the way whenever I set it up. So that was kind of the motivation, is that it's a mess all around the camera here because I'm redoing my shipping area, and then sometimes I take my daughter down here, and then she takes that stuff that I was trying to clean up and put in here temporarily, and she throws it all over the floor. So it's a super mess in here, and I just kind of wanted to do this here before I clean it all back up, get my shipping area situated again, and get this done. But In any case, that's all I've got for now. Thanks for watching, if I ever post this. All right, one last thing. So I just ended the video. I thought I ended the video there. I was throwing myself a little pity party for messing up this whole thing with the wall sizes and all that and the printing parameters, right? And I hadn't even tested the glass-filled ABS, which is, when I started the video, I said that I had tested this grip in ABS glass fiber in this rig at 1,500 pounds, or I show you that, right? And I was about to just stop because I was feeling bad for myself for, getting all this wrong. And I've got other stuff going wrong in the machine shop as well. And whatever, I'm just feeling bad for myself, right? And I was about to go, take a walk or something. And, I said, just put in the ABS, right? And it tested the lowest by far. It seems that the parameters are similar, and on some of these I actually did start writing my parameters on it. And for the glass filled ABS specifically, I wrote at least the amount of walls that I put. So I need to at least write the walls and the infill parameters and stuff on these. But regardless, it seems pretty similar to how I printed the PAHT, right? So I have a pretty good comparison here to two materials that I am using. And so for the horizontal orientation, I'm getting low to high 90s on the ABS glass filled, whereas on the high I was getting low 180s on the PAHT, twice as much. And then same thing with the vertical orientation, or pulling the layers apart. I've got low 30s or low 40s for the ABS glass fill. And then I've got low 70s for the PHC, carbon fiber, which is my material of choice. Again, I don't know that these are exact comparisons, honestly, or the PHT carbon fiber. What I still have yet to do is I need to run some calibrations. Not totally necessary, but to get the absolute best amount of strength that I can from these, I'd like to run some calibrations. So temperature towers, like flow rate calibration, all that I want to do for this specific material and brand and everything. And I also want to run some chamber temperatures, because I do have a machine that has a heated build chamber for the printer for this PHT carbon fiber. So what I'm trying to say is that I think that I can squeeze some additional layer strength out of this. So the layer strength is dependent on what temperature I printed at, but as you get to elevated temperatures, the surface quality can degrade, like it'll look worse. So I need to balance that, but again, I think I can squeeze a little bit of strength out of here, and at the end of the day, it's all unnecessary. The way that I ended up designing this, because I did increase the wall thickness at points where it was breaking here, and wall thickness, so increasing the moment of inertia in the areas that were failing when I was doing that hydraulic test, or is again something that I would have seen when doing the test here as well. And then again, adding this insert holder is, honestly, I've already kind of proven my point that I'm going to test these grips, but I've already tested them in a much weaker material, i.e. the ABS glass fiber, and I'm using this, which is harder wearing. It's a stiffer, which the stiffness doesn't matter a lot, but the ABS glass fiber, if you're using this in like a deadlift scenario, lifting weights or pulling on a force gauge, you can kind of feel the ABS glass fiber flex in your hand, which this just has a more solid feel. So I did mess up my tensile strength tests, and my setup is kind of garbage as well. I'm kind of able to get higher numbers if I try and go slower on the chain hoist. So it's not a very good method, but I think it did confirm, even though not in a very scientific or controlled way, that I'm doing my due diligence here, and at least trying to test these materials to make sure that these are good. So again, I did at least test the layer adhesion and overall strength of this material in comparison to something like a glass, the ABS. So an ABS would work, but I'm going once further and I'm using a much better filament, which should last longer. So not only is it strong enough now, but even if this does degrade, which will be much slower than a PLA or an ABS or whatever, it still should have the amount of strength that you need for years to come. So with that, I've got some more testing on this I want to do. I've got some dialing in of tolerances, the machining process and stuff like that. And I also want to like probably watch TV for like a week where, or like movies or whatever, and just go like this over and over and over again to get, you know, more pulling off and putting back on than anybody in a real scenario would ever do. Like, you know, no one would ever pull this off and put it back on as many times as I do. You know, I can't really easily build a machine to pull this off and on to test like a fatigue test, but I want to do that and see what happens. You know, not just take it for granted that this will come on and off the way that I hope it will for years to come. I want to at least do it like as many times as my hands can conceivably do in a short amount of time to test these out before I put them into production and get them going. There's a few people that I'll send these out to test as well, get some additional feedback before going live with this. So again, that's it. Threw myself a pity party, but again, this wasn't the best test, but I think I learned enough from it. And a lot of times when I do something like this, I'm kind of the personality to kind of shoot from the hip from the beginning. And yeah, I loaded my printer up, the slicer settings and stuff, kind of willy-nilly. But you know, now I know I have the pain of having done this wrong and know that I can't really trust these results. So in my spreadsheet, I'm going to put the settings. I'll save templates for the strength testing specifically in each slicer that I use. So moving forward, I won't necessarily use the data that I took here in the future. I still need to set a better start point than this, but certainly the printers that I'm using in the materials that I'm using are more than capable of creating like a really nice grip for this. So that's it. Thank you.